It's lesson time. Yes, well, welcome to 5th grade to the both of us. We're in 5th grade now. We made it. And you'll be glad to know, I'll just say briefly, I consider 5th grade kind of like 4th grade part 2. Because a lot of Eureka math will build on what you did so successfully last year in 4th grade. And I know you're successful because here we are in 5th grade. Big time. Let's do it. Lesson 1, Module 1. Our objective. Okay, so we're going to reason concretely in real ways, like stuff you can see and perhaps even touch in a virtual sense, and pictorially, that's right, with pictures, using place value understanding. So, we're going to go all the way from millions down to thousandths. And you see why I call 5th grade, 4th grade part 2, because really all we're adding here is thousandths. That's it. You can do that. So let's do it. There is a sprint for lesson 1 where you do lots of times 10 here. So do that. Grade yourself. Do side B while you're at it. Why not? Have a good time. And then note your improvement. All right. So we're going to start off warm up here by renaming some units. Yeah. If you have 10 ones, how many tens is that? 10 ones. Yeah, that's 110. Okay, so 20 ones would be, good. 2 tens, how about 30 ones? 3 tens, good. 80 ones, 8 tens, and now we're going to step it up a bit. 90 ones, 9 tens, here it comes. 100 ones. Yeah, now think about this in terms of money, right? 100 $1 bills would be 10 $10 bills, right? So 100 ones, 10 tens. How about 110 ones? 11 tens. I'm just going to give you a little sneak preview here. Look, if you kind of like in your mind mentally, the way of thinking of this is, using place value. Oh yeah, okay. 110 ones, 11 tens, moving those over, right? Get it? Okay. 120 ones, 12 tens, good. 170 ones, 17 tens, you got the hang of this. What if you have 270 $1 bills? How many $10 bills is that? 27, great. You can work at a bank now. 670 ones, 67 tens, how about 640 ones? We'll go backwards now. All right, 64 tens, good. 830 ones, 83 tens, how about, oh wait, hold on. You notice here, I didn't give you anything other than a 0 in the ones place here. Why is that? What if I put if this was 831? Well, that would be 83 tens and 1 1. That's what you'd have to say there. Or if it were a 5, you'd say 83 tens and 5 ones. So just to give it in tens, we can't have any ones. If we did, we could just deal with them in a separate unit. These are units. Remember unit form? Oh yeah, I remember you. Look at this. Oh, I've missed your place value chart. And here it is. All right. Enough of the love fest. All right, let's fill this bad boy out. I put question marks. There's a Riddler or something. All right, let's start at the left. My left. Anyway, hundreds. What's there? Tens, then ones. I put a place kind of for the decimal point just so we don't forget it, and I made it nice and big so we can see it, but of course it's not a place value. I'm just putting that there. All right, so the next place is tenths and then hundredths. Okay, and a little bonus question, go figure out why there's no oneths. Think about it. All right, how many tenths do we have here? Easy question. I'm not trying to fool you. No math to do here, except for counting. Okay, there are 3 tenths. Okay, right. Now, how many ones is that? Yeah, 3 tens and 0 ones. So 3 tens is equal to 30. Okay. And you're like, yeah, Mr. McGrath, we know that. All right, and I'll step it up. Don't worry. Okay, what do we have here? Oh, yeah. We have 3 tenths. Okay, so 3 tenths, how would we write that in standard form? Standard form is a regular old number. We have it in unit form here, by the way. Remember, unit form gives us a numerical number. and then the place value, 3/10, that's unit form. Now we're doing standard form. 0.3 is how we'd write it, although we'd say, of course, 3/10. That's how you read it. So 2 ways to talk about numbers when you're dealing with decimals is how do we write it, I'll say, and then you'd say 0.3. Or if I say how do we say this, or how do we say this as a math number, or read this as a number, you would say 3/10. 0.3 is just instructions for writing it. It's not the name of that number. Yes, I'm picky. All right. And now what do we have? 4/10. How do we write that? 0.4. We say 4/10. Good. How's about them apples? We have 3/100ths. Yeah, so 3/100ths. How would we write that in standard form? 0.03. Ah, yes. This is all 4th grade stuff so far, right? Told you. Oh, well, this is different. Now we have 2 things going on here at once. So that's 34/100ths. And my way of thinking about this is to read the number as a number on this side of the decimal point. Did I say 34? I should have said 43. We just read it as a number, 43, and then we say, what place am I in? Hundredths. So you read this as 43/100ths. So let's say it was 7 and an 8. You'd say 78, where am I? Hundredths. That will become even more relevant when we meet our new friend, thousandths, very soon. 43/100ths, how do we write that as a decimal in standard form? 0.43. Very good. How's about this? We have 3/10, 5/100ths. Read that as a number. 35, what place am I in? Hundredths. Very good. 35/100ths, write that as a decimal. 0.35. Excellent. Okay, look, I kept the 35/100ths there, and so now over here we have 7. So 7, the decimal point is when you do say and in math. And this is another thing I'm picky about, because this lesson 1 I'm going to get picky with you. Like, for example, if you had the number 122, or let's do 123. 123. That's 123. It is not 123. Now, sometimes in writing and common talk, or even I will sometimes just say it with the and. That's common. It's not a problem. But when you're being particular about math, you do want to be particular. This is when you do say and. It's 7 and 35/100ths. 7 ones and 35/100ths. So how would we write that? This is actually kind of easier, isn't it, to write it in decimal form, standard form, 7.35. Excellent. All right, so now we have 9 ones, 2/10, 4/100ths. So the 2/10 and 4/100ths, we read that as 2, 4, 24. Where am I? Hundredths. So 9 ones and 24/100ths as a decimal. You got it. 9.24. Excellent. This doesn't change anything. We have no tenths. So read this as a number. Well, there's no tenths, so I'm just going to say 4/100ths, right? And then what do we have back here? 62. So 6/10, 2 ones, and 4/100ths in proper unit form. 6/10, 2 ones, and 4/100ths. 62.04. Yeah, 04. Yeah, $62.04. There's your paycheck. Go cash it. Oh, Farmer Jim. Hey, Farmer Jim. If your name is Jim right now, I want you to give yourself a high five. All right. He keeps 12 hens in every coop. That's compassionate farming. If Farmer Jim has 20 coops, and a coop is a hen house, it's where you keep hens. And the hens are the females that lay the eggs. Roosters don't lay eggs. And you can't keep them in your backyard. How many hens does he have in all? If every hen lays 9 eggs on Monday, how many eggs will Farmer Jim collect on Monday? Explain your reasoning using words, numbers, and pictures. Let's get that again. There's a whole lot going on there. 12 hens in each coop. 20 coops, how many does he have in all? Okay, let's work with that first, because we have 2 questions here, right? All right, so how many hens in all? We have 12 hens in every coop. Okay, so here's how I could draw this out. And I'm just going to kind of, because this is lesson 1, remember doing multiplication with area models? this is how you can break it down. And I always encourage my students to do this mentally instead of doing the upstairs, downstairs way of doing multiplication, which is useful. But sometimes you can do it this way and get a more accurate answer, less likely to make mistakes. So here's my 12, right? The 10 and the 2. Now, if I had 22 or something, I would have a second row here, but I don't, thankfully, so it's a little easier. All right, so I have 20 times 10 will go in this first. You see, that's 20 times 10 land, and this is 20 times 2 land. Got it? Okay, so what is 20 times 10? Well, we know, ride that times 10 slide. You learned that in 4th grade. So 20 times 10 moves up the place value chart to 200. 20 times 2, well, double 20. Good, 40. Put them together. He has 240 hens. 240 hens. Great. Now, if those hens get busy laying 9 eggs on Monday, now does Monday have anything to do with anything? No. See, so sometimes in these questions you'll get a little bit of extra information. You'll think, does that mean? It doesn't matter that's Monday. It could be any day of the week or just on a day. So every hen is going to lay 9 eggs on Monday. They're in sync. How many eggs will he collect on that day on Monday? So now we're going to take the number of hens, 240, and each of those 240 hens is laying 9 eggs. 240 hens lay eggs 9 times. Get that? 9 times they're going to lay eggs. So that times there gives you a clue that we're talking about multiplication. And I can set up with a similar area model. 9 times 200 land right here. 9 times 40 land. Well, to do 9 times 200, you remember this from 4th grade, do 9 times 2 times 100. So 9 times 2 is, good, 18. And then times 100. 1800, also known as 1800, but 1800 works. 9 times 40, same thing. Do 9 times 4. You know that one? 36. Yeah, get that brain back in action for a new school year. So 36 now times 10, 360. Okay, so now we have to put those together. So go ahead and add 1800 with 360. Well, 0 and 0 are 0, 0 and 6 are 6, 8 plus 3, 11, regroup the 1, 1 and 1 are 2, so 2,160 eggs. Go, Farmer Jim! And you always need to write out a statement there. All right. So here we go, into the core of the lesson. What we're going to be doing here is dividing single units by 10 to build the place value chart to introduce you to your new friend, a pink hippo named Boo Boo Butt. No, that's from a book. If you get a chance, look up the book with no pictures by B.J. Novak. It's very funny. Have someone read it to you, no matter how old you are. All right, so we're going to build a place value chart to introduce thousandths. Here we go. Here he is, our new friend, thousandths. Oh, isn't he cute? He's little. I had to make the font small to make this thing fit on one slide. Golly. All right, so let's start by showing 1 million. Look, there it is, 1 million. So how many hundred thousands is that 1 million? Okay, well, what we're doing is decomposing. Remember that word? Decomposing it, busting it out. If you have 10 hundred thousands, that makes 1 million, okay? So there's no mathematical operation going on here. We're just regrouping, decomposing, right? Okay, so those are equal. All right, so now, what if I instead were to divide 1 million by 10? Well, I bet you recall from your extensive experience in 4th grade that when you divide 1 million by 10, you're going to move it down the place values chart here, right? Millions to hundreds. So you just bloop, there we go. Divided by 10 goes down. And remember, I'll just mention it, times 10 is going to move up the place value chart. So 1 million divided by 10 is 100,000. Let's keep going faster now. So how would we write that as a division sentence? There it is. 1 million divided by 10 equals 100,000. That's what it looks like. All right, so now, this is something that you got to wrap your head around because it's on the test of life. 1 million is how many times, greater or smaller, than 100,000. A million is, well, it's bigger than 100,000, right? Okay, all right, so we know we're looking at greater than, but how many times greater? Yes, 10, and guess what? I'm giving you all the answers at once. The answer is always going to be 10, whether it's greater or smaller when we're talking about the place value chart, because every place is 10 times greater than the one before it, or 10 times smaller than the one after it. Okay, so it's 10 times larger than 100,000. Great. Now, 100,000, flip it, compare it to 1 million. 100,000, okay, well that's smaller than 1 million. How many times smaller? Again, I told you the answer is 10 every time. It's 10 times smaller than 1 million. All right. How can I do that with a fraction? 100,000 is 10 times smaller than 1 million. Okay, let me just show you this one. 100,000 is 1/10 of a million. Think, what? Yeah, say what? All right, think about it this way. A penny is 1/10 of a dime, right? Because you need 10 of them to make a dime. So a penny is 1/10 of a dime because the dime is 10 times greater. Same thing here. 100,000 is 1/10 of a million because a million is 10 times greater. Hallelujah. All right, now we're going to keep going. What's 1/10 of 100,000 divided by 10? Yep, we're going to go down the place value. Divide by 10, 1/10,000. A 10,000, 10,000. Okay, so 1/10,000, to put it in unit form, is, well, is that greater or smaller than 100,000? It's smaller. Okay, so smaller. How many times smaller? You remember, the answer is always 10. It's 10 times smaller than 100,000. So 100,000 compared to 10,000, well, that's the bigger one, right? So this is greater. 100,000 is, and notice I'm showing you how to do these. So when they ask you compare 100,000 to 10,000, you say, okay, 100,000, is that greater or smaller? Okay, it's greater. Okay, how many times greater? 10 times greater. Hallelujah. Or larger. Now you know what to do. Let's keep going. We're going to walk right down the chart. We're going to speed it up now. Okay, we're going to divide by 10. 10,000 divided by 10, 1,000, of course. And so a 10,000 is greater, yes, than 1,000. How many times? Answer is still 10. Very good. 10 times larger than 1,000. Let's keep going. Oh, well, sorry. First, 1,000 is compared to 10,000? It's smaller, right? It's smaller. How many times smaller? The answer is still 10. You got it. So 10 times smaller than a 10,000. Same thing, moving down. Oh, ooh, ooh, what's up with that? Oh, now we're going to compare 1,000 to 100,000. Was the 1,000 bigger or smaller than 100,000? It's smaller, but now how many times smaller? Oh, it's 2 place values. Oops. It's 2 place values. So it's 10 times 10 times smaller. Ah, yes, it's 100 times smaller. 100 times smaller. You see that? When you go 2 places, it's now 100. This is an important thing not to miss because we will be doing exponents soon, and this is highly relevant. Okay, so now flip that. 100,000 compared to 1,000. Well, it's larger. Okay. How many times larger? Well, the answer is no longer 10, right? Because we're going 2 places. So it's 10 times 10 larger. It's 100 times larger. Getting it? Don't worry, there's lots more to do. Ooh, what about this? Yeah, 1,000 compared to 1,000,000. Well, we know 1,000 is smaller than 1,000,000. How many times smaller, though? We're going times 10 times 10 times 10. We're going 3 place values here. 10 to the third, you will find out soon. We're going 3 place values here. So 10 times 10 is 100 times 10. 100 times 10 is 1,000. So it's 1,000 times smaller. So 1,000 is 1,000 times smaller than 1,000,000. So if you have a friend who makes $1 million a year and you make $1,000 a year, he makes 1,000 times more than you. Woo! Time to catch up. And that's exactly what we're going to do. 1 million is, okay, it's larger than 1,000, definitely. How many times larger? Well, we're going 1, 2, 3 places here. 10 times 10 times 10, it is 1,000 times larger. A million, your friend makes 1,000,000 times more than you. Very good. Can you tell me why? Well, we kind of discussed it here, but we're doing 10 times 10 times 10. Okay, so 2 places is 10 times 10, 100 times greater, times 10 is 1,000 times greater. If we went another place, 4 places, 10 to the 4th, it would be 10 times 10 times 10 times 10, which is 10,000, and so on. Let's not do that. Okay. But it's important to understand that the same thing works in reverse with division, right? Because that's when we were doing, oh, it's this many times smaller. So when you go from millions down to 1,000s, it's divided by 10, divided by 10, divided by 10, divided by 1,000. When you're going 3 places, if you're going 2 places, it's divided by 10, divided by 10, it's 100 times smaller. Getting it? This is essential. I tell you, everything in this first module is essential to your success in 5th grade. I'm taking a little bit more time on this than we will in future lessons for that reason. We're going to walk down the rest of the place value table. Here we go. This is where things actually will speed up a little bit. All right, so thousands divided by 10 is 100, right? 1,000 divided by 10 is 100. We're just going one place again. So 100 divided by 10, 10. You can see that, right? 10 divided by 10 is 1. Did you say 10? You said 1. Okay. 10 divided by 10 is 1. Now think. 1 divided by 10? Yeah, just go to the next place. It's 1/10. You see the division here? 1 divided by 10 is 1/10. Because think about it, a fraction expresses division. 1 over 10, you read as 1/10. Hallelujah, it all makes sense. All right, how about a tenth divided by 10? 1/10 divided by 10. The 100th. Here we go, we're about to meet our new friend. 100th divided by 10 is 1,000ths. Ha! We made it. Now we can do the magic. Now that you've learned all that, we can work a little math-o-magic here, all right? So take this 4 times 10, 40, right? You just move that 4 up the place value chart. Boo! 40 divided by 10, you go down the place value chart. It's 4. How about 4? Ooh. This is something you could never do before, I bet. 4 divided by 100? You're like, wait, do you have that backwards? Don't you mean 100 divided by 4? No, I do not, my friend. I am saying 4 divided by 100. You're going 2 places. Now, don't mistakenly count the decimal point as a place. We talked about that. Tenths, hundredths. That 4 is going to go down to tenths to hundredths because we're dividing by 100. So we're moving 2 places on the place value chart. So 4 divided by 100 is 4 hundredths. Again, think of the fraction. 4 divided by 100 we could write as a fraction. Fractions express division. 4 divided by 100 we could write as 4 over 100, and we read it as what? 4 hundredths. Ah, the beauty of math. 4 divided by 1,000. You can do this. You already said it. All right. But we're going 3 places, right? Times, we're multiplying. All the way, we're multiplying. We're going to go 3 places. Times 10, times 10, times 10. 4 times 1,000, 4,000. Okay. 4 thousandths divided, or times, 4, let's start over. 4 thousandths times 1,000. 1, 2, 3 places it's going because we're multiplying by 1,000. Yeah, it's going to be 4. Okay. 4 thousandths times 100,000. I know you're like, Mr. McCarthy, you're crazy. Yes, I am. Sorry. All right, but let's do this. I'm going to show you a little shortcut here just to make life easier because we understand how it works, and you can only use shortcuts when you understand what you're doing. But the little shortcut is you notice like when there's 2 zeros in the number, you're going to go 2 places. So times 100, there's 2 zeros in 100, you go 2 places. Well, we can look at this to make sure we don't mess up and say, oh, there's 5 zeros in 100,000, we're going 5 places. We could also break that out as 10 times 10 times 10 times 10 times 10. Okay, 1, 2, 3, 4, 5, it lands in the hundreds place. So 4 thousandths times 100,000 is 400. Whoa, you're good. More math magic. 24 times 10. Shift both numbers. Yeah, you know, up that place value chart. 2, 4, and now we have to place a 0 here because we have 0 ones, right? 240. 24 times 100, that's right. Both digits will move up 2 places because it's times 100 now. 2,400. How about this? When we divide 24 by 10, we're just going, each digit's going down the place value chart, 1 place, dividing by 10, we end up with 2 and 4 tenths. Remember, that's the math number. If I said, how do we write it? You'd say 2.4. But when I say, what is 24 divided by 10? You say 2 and 4 tenths. All right, how about 24 divided by 100? Both digits now are going to move 2 places. 1, so the 2 here in the tenth place will go 1, 2 place to the tenths. The 4 in the ones place will go 1, 2 place to the hundredths. Looks like that. How would we read this? Don't say 0.24. And I do have students occasionally will say 0 and you just don't need to do that. Like nobody does that. I mean, it's not like incorrect. It's not cool either. Okay, so we read this. Remember, to read these decimal numbers, read it as a number. 24. What place am I in? Hundredths. 24 hundredths. 24 divided by 1,000. Now both digits are moving 3 places. So the 2 is going 1, 2, 3 place to the hundredths. The 4 is going 1, 2, 3 places to the thousandths, and it looks like that. Again, this is where the magic comes in. Read it as a number. 24, what place are we in? Thousandths. That's how you read that number. You just say, what do I have here? And even if there was a 0 here, it's written out as a regular number, as you see at the bottom there, 0.024 is how it's written. You look at that and say, what do I have after the decimal point? I have 24. What place am I in? Thousandths. 324 times, going the other way now, times 100, all 3 digits will move 2 places up. So the 3 will end up in the 10,000ths, the 2 will end up in the thousands, the 1s will move up to the hundreds. We end up with 32400, which we read as 32,400. Little note there, to be picky, you don't say and, you don't say 32,400, you say 32,400 because and is used in mixed numbers and decimals. All right. Now we're going to do the same thing, but dividing that same number by 100. So all these digits are going to go 2 places down the place value chart. So 324 moving 2 places down. Okay, so the 3 from the hundreds, divide by 10, ends up here. The 2, divide by 10, ends up in the tenths place. The 4, divide by 10, ends up in the hundredths place. So 3, let me go back for a second. Read that as a math number. 3 and, that's where you say and, 3 and 24, where am I? Hundredths. 3 and 24 hundredths. Okay. 324 divided now by 1,000. So each digit's going to move 3 places. Looks like this. 1, 2, 3. He ends up in the tenths place. 1, 2, 3. The 2 ends up in the hundredths place. 1, 2, 3. The 4 ends up in the thousandths place. Look at the number at the bottom. We don't have to say 0 and. We just read that as a number after the decimal point. 324. What place are we in? Thousandths. 324 thousandths. Whew, you did it. You're onto the problem set, and look at what you're doing here because you paid such wonderful attention. These are very similar to what we were just doing, aren't they? Times 10, times 100, times 1,000. So notice A, B, and C here. It's the same number 3 times, times 10, times 100, times 1,000. And you don't even have to draw the disk, just write the digits. It's a lot easier that way. And then same thing, different number, 345, but now you're going to divide by 10, divide by 100, going 2 places, divide by 1,000, going 3 places. Now look at D there. Explain how and why the value of the 4 changed in the quotients A, B, and C. Okay, quotient is the answer, so that's what they're asking about. Because in 345, the value of the 4 is 40 every time. But, so we're just talking about the quotient. So here, for example, the quotient they give you is 34 and 5/10. The 4, its value is now in the ones place. So I'm helping you at D because you have to write out a good answer here. Don't just say, it's smaller. Oh gosh, please don't do that to me. All right, we're going to say, what did we learn in the lesson? The 4 in this quotient is, compare it to the 4 here. We're comparing 40 with 4. Or actually, we're comparing 4 with 40. 4 is, yeah, we just did this. 4 is smaller than 40, isn't it? How many times smaller? It is, hallelujah, 10 times smaller. So you would say in A, the quotient 4 has a value 10 times smaller than the 4 in 345, whose value is 40. If you wanted to give a really complete answer, that's what you're looking at there. And you should. And then you have a couple of word problems, as per usual. You always do, right? Well, almost. And so here you're doing the same thing. All right, so 7,234 boxes of stirrers. If you're unsure on any of these, gee, do I multiply or divide? Here's my hint. Think about it. If I have 7, that's a lot of box of coffee stirrers with 1,000 in each box. How many stirrers did they make? Well, let's say you did the wrong operation and you ended up with a number that was around, I don't know, like 7. So they made 7,000 boxes and that resulted in having 7 coffee stirrers? I think something's wrong there. Okay, so use the does my answer make sense question to check these, because if you are off with multiplication or division, it's going to be obvious, all right? And then you have 2 more there. Same thing with the microscope. How long will the insect appear? Well, in the microscope, it's going to look bigger than it is. So if you end up with an answer that's like crazy small and doesn't make sense, you'll catch that, all right? Exit ticket, very simple. Just note, important here, this one's times 100. This one's divide by 1,000, okay? And they do not tell you in the instructions here, hold on, let me go back up. No, it says use the place value chart, but it does not instruct you to label the place value chart. So I'm not going to require my students to. Ask your teacher if you're supposed to, but the homework, same thing. Same as the problem set, just different numbers. Exactly the same, just different numbers. And look what you've done. Now, this lesson was a bit longer and more intense than they probably will be down the line. That always happens with Eureka Math. In every grade, it seems like this Module 1 lesson is a doozy. So if your head is spinning, that's fine. Get up, go for a walk, get outside, get a glass of water, chill, all right? And then come back and look at this again, and it'll start to, coalesce in your mind, okay? So we won't always go quite so long and intense, but it's a great way to start 5th grade. Congratulations. You look what you've done. You've gone and finished your first lesson time for the year, and I will then see you again next time. It is, once again, a lesson time.